Hello, welcome to today's physics class. In today's class, I will be showing us how to calculate questions on the topic friction. Okay, so let us look at how questions are set under this topic. So let us look at the question on the board. So the topic says calculating friction. So the question here says a box or a 10 kg box lies on a flat surface. Full stop. The coefficient of static friction is 0.4. A. Find the maximum static friction. B. If the box is pushed by 50 Newton, will it move? It's a question. So let us go. So we understand that what a flat surface, let's say this is the flat surface, okay? Now a box, this is the box. A box, okay? Then they said, or the question says that 10 kg, okay? Now this box is exerting a weight on this object, which is W equal to what? mg, okay? And in turn, the surface is also exerting a reaction force, which is also known as what? Normal reaction. So from here, the normal reaction will be acting upward from the surface. That is your normal reaction. Call it N, or you can call it R. Now, there is a force which will tend to stop this object from sliding over the surface, and that friction is acting opposite the motion of the object. So now, according to the question, the body is at rest. So for the body to move, so there has to be an application of force. This is therefore applied force. Okay. So this is the applied force that will push this object. Now there is a kind of resistive force, which is the static friction now we are talking about. So there is a static friction because the body is already at rest. So we are not considering a static what? Friction. So the question says find the maximum static friction. Good. Let us go. We are told that one of the laws of friction says that the limiting frictional force, which is this F, is directly proportional to the normal reaction. Good. So now removing the proportionality, that is where we now have the coefficient of static friction. This one is not static friction, then multiplying by the normal. So this is the formula we are going to use now to calculate this. And remember, the normal here is equal to the weight of the object according to the Newton's law of motion, the third law. The third law said that to every action there is equal and opposite reaction, which means action and reaction they are the same. So here is the weight exerted on the surface, and the force of reaction is equal to the weight. So which means our weight here is what? Mg. So your N is now equal to mg, which is the weight. Good. Remember that we are given that from the question, the coefficient of friction is 0.4. Then we are also known that g, we are needing g. Let us use 9.8 meter per second squared. So from here, we can just plug in those values. The static friction is equal to 0.4 times 9.8. Good. Times, because the mass, we are talking about mg, times 10. Times 10, okay. So that's mg, 10 times this. So 0.4, 9 times this, 9.8 times this is going to give us 98, which now give us f of x is equal to 0.4 times 98. So let us multiply it. It will give us 39.2 newtons. It's equal to 39.2 Newton. Good. So this is your A. We have just calculated for your A. Now let us go to the B. So B now says if the box is pushed by 50 Newton, will it move? Yes, the question is yes. For this body to move, the static friction has to be overcome. Yes, before the object or the body can move. So it therefore means the applied force is greater than the frictional force. so the body will move. So that is the answer. So you don't have any calculation, because for the body to move, it's going to be F applied force minus static friction equal to the acceleration, mass times acceleration. So it means the body is in motion. So since applied force 50 Newton, 50 is greater than 39.2, so the body will move. That is the answer to that question. If you find this class very interesting, help us to share this video, like and comment. If you have any question that troubles you, write it in the comment section. I will attend to you. Bye.